Go ahead.
Okay, so we have to find the solution, and our problem is negative 7x plus 5y equals 0, and 14x minus 8y equals.
Then you have to get y by itself, and you divide 5y by 5, and then 7x by 5.
Again, you need to get y by itself, so we subtract 14x, we get negative 8y equals negative 14x plus 3. And then divide by 8, so we can simplify it, and we get y equals 14 over 8x plus 3/8. Calculator work, you go to y equals on your calculator, and you'll type in these two new equations. So the first one would be y equals 7 divided by 5x, and then go to the y2, and it'd be 14 divided by 8x plus 3 divided by 8, and then you hit graph, and it'll graph it for you. And then hit second trace, and hit enter 3 times. Or actually, you want to go to second trace, 5, intersect, and then hit enter 3 times, and you should get, for your solution, negative 1.07 and negative 1.5, and your graph should look like that.
This is the solution you get when you graph it out drawing it, and the solution is negative 1.07 and negative 1.5.
Solve the following linear programming example. Write the constraints and objective function, graph the function, and determine the maximum and minimum according to the given constraints. The problem says, Sweet Treats Bakery makes pies and tarts. A tart requires 3 ounces of fruit and 2 ounces of dough. A pie requires 3 ounces of fruit and 7 ounces of dough. There are 140 ounces of fruit and 90 ounces of dough available. Each tart earns 6 cents profit. Each pie earns 25 cents profit. How many tarts and pies should Sweet Treats Bakery produce to obtain the maximum profit?
So to start the problem off, we make this little chart, and we split it up into pies, tarts, and then the total. And you have to make sure you keep like the fruit and the dough together. So for the first problem, we have 13x, and that would be for the 13 ounces of fruit, and then that would be added to 3y, which would be the 3 ounces of fruit and the tarts, and then it would be less than or equal to 140 ounces of fruit, because the total is 140, you can't have any more than that. And then the bottom one would be 7x, because there is 7 ounces of dough, plus 2y, which would be 2 ounces of dough for the tarts. And then same thing with that, would be less than or equal to, because there can't be no more than 90 ounces of dough. So that's the total. And then that goes into the solution being x equals 10.77 and y equals 46.66, and the bottom one would be x equals 12.86 and y equals 40.2.
I have 2 more constraints. X is greater than or equal to 0 and y is greater than or equal to 0, because you can't make negative pies or negative tarts or negative anything. And then the objective function is for the profit, and it says here that each tart earns 0.06 profit and each pie earns 25 cents profit. So then C equals 0.25x plus 0.06y.
You take these two equations, and you take x and y and plug them in over here, and then once you find where all the intercepts, you map out the points, and then to find the intersection of the 2 lines, you take this and plug it in with this equations.
Because you gotta find you don't know the exact point of this point, so you have to take the 2 lines that they're formulas that cause the intersection. And then you'll get x equals 2 and y equals 38. And then also don't forget your x and y, these ones, so plug those in, and then you'll just map them. Point start at 0, map up and down, and then you plug in 0 to these formulas. So if you plug in 0 here, 0 is less than or equal to 140, so yes, it's true, so you should turn 0. Same with this one. And then for these ones, you would plug in like 1 or something. So we plug in 1 here, and it's true, so we shade towards 1, and then here we plug in 1, it's true, we shade towards 1, and our shading would be all in here.
After finding all the points on our graph, we take all those points and we plug them back into our objective function, which was way over here, 0.25x plus 0.06y. And our answers, whatever we get, whatever is the lowest would be our min, and then the one that's the highest would be our max, and we just use those points. And our we need the max because you can't have a zero profit. So you take the max and then the points are 238, so that gives you 2 pies and 48 tarts. Wait,
That's
supposed to
okay.
be 38.
Typo.
38 tarts. Scratch that. 38 tarts and 2 pies.
Number 3 is solve linear system, and it's 3x plus 6y plus 6z equals 3, x plus 3y plus 10z equals negative 10, and x plus 2y plus 5z equals negative 11.
So to solve this, we need to take the first two equations, and we're going to solve this by using elimination. So with these two, we're going to multiply the second problem by 2 to make the 3y a 6y also. So then over here, it would be 3x plus 6y plus 6z equals 3, and then negative 2x minus 6y minus 20z equals 20, and you would cross out the 6's because they cancel, and then you would get x equals 14z equals x minus 14z equals 23, and that would be your new first equation.
To get your second equation, you take the bottom two equations, and you want to cross out y again. So you times the first one by negative 2, and then you get 2x plus 6y plus 20z equals negative 20, and then negative 3x minus 6y minus 15z equals 33. And then your second equation equals negative x plus 5z equals 13.
So then you just take the two new equations, and then we use elimination because the x's already cancel out, so you pass out the x's when we're solving for z. So we get negative 9z equals 36, so we divide by 9 and get z equals negative 4. And then you can plug z into one of the two new equations, so we did this one. So we get negative x plus 5 times negative 4, which is z, equals 13. And then we solve and got negative x equals 33. So then you divide by 1, so see what x is instead of negative x. So then x is negative 33. And then you have to plug x into one of the old equations. So you plug it into this one. And we get negative 33 plus 2y plus 5 times negative 4 equals negative 11. And we solve for that. And we get 2y equals 42, so we divide by 2 and get y equals 21. Final solution is negative 33, 21, and negative 4.